18 says the area of this triangle is 21. What is the value of x? And you can see this diagram gives you both the height and the base length here. So this is the height, and the height is just equal to x. The base here, which is the distance from here to here, is going to be x plus 1. So to answer this, we really need to know how to find the area of a triangle, and that formula is going to be given here. Area equals 1/2 times the base times the height. Okay, and just to be very clear here, A is the area, B is the base, and H is the height. I want to make sure I don't leave anything, I don't want to have any ambiguity here. Okay, so it says the area of this triangle is 21. What's the value of x? The area is 21. 1/2 times the base, which is x plus 1, times the height, which is x. Okay, so we're going to multiply these together. Okay, so now the question here is asking what x is. So you probably could get away at this point, once you set up this equation, with using your answer choices to figure out what the right answer is. I'm going to go through with you on the algebra and how you would solve for x here. That way, if it's, looks a little different, or if it's an open-ended question, you could still answer it. But here at this point, what I would do is just plug in the answer choices into x and see which one gives you 21. So just like really quickly, like if x is 3, x plus 1 would be 4, right? So 4 times 3 would be 12. Half of 12 is 6. It's not 21. I throw in 6 here. 6 plus 1 is 7. 7 times 6 is 42. And half of 42 is 21. So we know what our answer is going to be here. It's going to be B. You could check 7 and 11 and see that they're not right. But I do want you to know that that is a solid strategy for answering these multiple choice questions. Now, I will go through the actual algebra here, but honestly, it's pretty overkill for answering this question because it is multiple choice. But, since I've got you here, and if you want to see how you would actually solve this for x, let's work through it. So first, I'm going to rearrange this. Multiplication has this property called commutativity, which means that the order doesn't matter. In other words, 2 times 3 is the same as 3 times 2. And so since I'm multiplying 1/2 times x plus 1 times x, just to make this a little easier to read, I'm going to rearrange the multiplication a little bit, and I'm going to move this times x over here. Okay, 1/2 times x times this. I really don't need these little dots here. I just wanted to show you how the commutative properties would play out here. I'm going to delete those. Okay, if you don't see a symbol in between a number and a variable like this, it's assumed to be multiplication anyway. So then from here, you would distribute the 1/2 x, you'd use the distributive property, and multiply 1/2 x to both x and 1. Okay, what we're doing here, just, I'm kind of going off in the algebra here, but what we're trying to do is rearrange this equation so that we can isolate x. And to do that, well, we have what's called a quadratic equation here, which means that we're going to end up with an x squared, which you're going to see here, 1/2 x squared plus 1/2 x. And yeah, so anytime you've got a quadratic equation, in order to solve that, you're going to have to set it equal to 0 so that we can factor and use the zero product property. Like I said at the beginning, like the algebra here is going to be way overkill for trying to answer this question. I would definitely recommend just plugging in these numbers to see which one would work. It's going to be way faster to do it that way. But anyway, here's how it would play out. In order to solve this, I do need it to be 0, so I'm going to subtract that 21 from both sides. That's going to leave me with 1/2 x squared plus 1/2 x minus 21 equals 0. Now the fractions I'm going to try to get rid of. Kind of annoying to have those fractions in there, and factoring will be way easier without them. So I'm going to multiply both sides by 2. Okay, so just to kind of show you what I'm doing here, I'm going to multiply this side by 2 and this side by 2. I'm allowed to do that because I'm doing it to both sides. I have these properties of equality that allow you to essentially do pretty much anything you want to the equation as long as you do it to both sides. There are some, special cases here and there where that doesn't work like that, but for the most part, you are allowed to do that. So when I multiply this whole thing by 2, it's going to clear those fractions, because 1/2 times 2 is 1, and that's kind of what I'm trying to do here. I'm trying to make this a little simpler so I don't have to deal with the fraction. So yeah, I'm going to end up with x squared plus 1x, and it looks like I'm going to be stuck with a fraction either way. Oh, no, I'm not. No, never mind. Okay, 42. Yeah, I just had a little brain fart there. Okay. So now we can factor this, and to factor this, we're going to find two values, or two numbers that multiply to give me negative 42, add up to -1. That's going to be positive 6 and negative 7. Oh, I think I just, you know what? This is supposed to be plus. Sorry about that. That's going to make this -6 and plus. Little error there. Okay, there we go. So yes, so two numbers that multiply to give me -42 but add up to 1 is going to be -6 and positive 7. Now I can use the zero product property, which allows me to set each expression, each factor rather, equal to 0. Basically what it means is that when you have two things that are being multiplied together, if it equals 0, then at least one of those things has to be 0. So either x minus 6 equals 0 or x plus 7 equals 0. You might be thinking to yourself, well, hang on, we're about to get two separate solutions, right? We are. Why is it just one of them? We'll see very soon why that is. Here, if I add 6 to both sides, I get x equals 6, which is what we knew the answer was from, like 5 minutes ago. But here, we get x equals -7. Now, sometimes in geometry, you end up, when you're trying to solve these geometric problems using algebra, sometimes you get what are called erroneous solutions, or sometimes they're called extraneous solutions. And basically what that means is it's a solution that you get from correctly working out the algebra, but because of some context or because of some reason, maybe it's a domain issue or something like that, or just the context of the problem, one of the solutions is just invalid. So for here, the -7 is going to be invalid, because you can't have a height that's -7 units, right? It doesn't really make sense to have a triangle where the height is negative. So the only choice we really have here is x equals 6, and we see that that's answer choice B. I just spent, kind of a bit of time here working through the algebra. You can see that there's kind of a lot going on here. Really want to emphasize that you can kind of cheat your way through these problems. You don't need to know all this algebra to get this right. Just plug in the answer choices and see which one works. I mean, these numbers are pretty small, so it shouldn't, take too much time to do 1/2 times 3 times 4, 1/2 times 6 times 7, 1/2 times 7 times 8, 1/2 times, what was the last one? I think it was 11, but let me double check. Yeah, 11. So 1/2 times 11 times 12, and see which one ends up equaling 21. All right, well, that's about it for number 18. Thanks for watching, and y'all have a great day.